So chapter 5, what we are going to study is the probability distribution. So one of the first question we are asking, what do you mean by probability distribution, right? Let's step back a little bit. Let's recall what we learned previously in terms of variable, right? If you still remember previously, we can break random variable into two kinds, right? The first one, discrete variable. We mentioned that is those integer valued, right? Countable case. So we have those examples. For example, number of students on campus or number of cars for each parking lot, right? So those are the integer valued. So we mentioned that previously. Now, for the continuous case, we say usually you will see either decimals or fractions, right? So that's the key difference. Later on, we will study each case. For the discrete variable, what is the probability distribution we have? For the continuous case, we will also study the corresponding probability distribution. So we will study both. And today we will start with the easy one. Which one is the easy one? Is the discrete variable. That is the relatively easy one. Okay, so everybody, if I try to roll a dice, okay, and I'm trying to list all the possible outcome, right? So we have 1, 2, 3, 4, 5, 6. That's the possible outcome we have, right? And I list the corresponding probability. Everybody, I'm using capital X to indicate, right? The potential value could be is either 1 or 2 or 3, the other, right? And I'm using PX, the corresponding probability for X equal to 1. Everybody, if you roll a die, what's the probability for you to get a 1? 1 over 6.
1, 6.
That's right. Similarly, if you roll a die, what's the probability? Got a 2, 1 over 6, right? Same for each one. Everybody, this table here is a very simple table, 2 columns. Is that right? 2 rows, right? What do we call this table here? We call this probability distribution. Is that easy? That's pretty easy, pretty straightforward. Is that right? So you list all the possible outcome, and then you calculate what's the corresponding probability. Put them in a table format. That's what we call probability distribution. That's the first easy example. Okay. Now the second example here, we want to construct the probability distribution for rolling 2 coins. Remember, we want to list all the possible outcome we have, right? So in that case, we can, if you still remember, we can use the tree diagram, right? The first one could be a head or tail, right? Based on the first one, the second one could be a head and tail, and we can read them directly for the possible outcome. How many? Altogether, we are getting 4 outcomes, right? So each outcome here, we have, like, for example, HH, that means head, head. The first coin head, second head, right? Now, everybody, the one that we are interested, right? We are interested if you roll 2 coins, flip 2 coins, how many number of heads we are getting, right? So in that case, I try to count each case here, how many number of heads I'm getting. Say is number of heads that we are interested. Sometimes, I mean, you may be interested number of tail, right? So depending on the question, right? Which one they are interested, right? So the first case, HH, we got a 2 head. Second, 1 head, right? It's 1 head, 1 tail. So we are writing 1 for number of heads, right? Third one, 1 head. Fourth, 0. Everybody, you see what's happening now? We started with 4 different outcomes. And then when we try to combine them together, X, everybody, X means number of heads. What's the possible value of X, everybody? Could it be 0? Could it be 1? Could it be 2? Right? We didn't see 3 here. Is that right? We didn't see -1 here. So we don't need to write down the other numbers. Okay? Now, and then we calculate what's the corresponding probability. Everybody, whenever we talk about a probability, remember something divided by something, right? Probability is numerator, that's the something that we are asking, right? Denominator, that's all possible choice we are able to get, right? So if we roll 2 coins, what's the probability for us to get a 0 head, right? So how many total possible outcome we are able to get? 4, denominator 4, right? Numerator is the case we are asking if we want to get a 0 number of heads, how many cases we have 0 number of heads? Everybody, we only have 1 case. So it is 1/4. Now the tricky part is for the 1 case, right? So how many case we have 1 heads? So turns out we have 2 cases here, 2 outcome here, they have 1 head. So it's 2/4, right? Similarly, for 2 number of heads, right? Number of heads equal to 2, we have 1 case here. Okay, so we have 1/4 here. Everybody, this table, what do we call this table? This table, we call this probability distribution table.
Professor?
Yeah.
So why is there a 1/4 underneath the 0?
Why there is, which one?
The one on the very left, 1/4, the one that's
Yeah.
below the 0? No, the very left.
The very left, this one here?
Yes, yes.
Okay.
What
What
does
do
it
you mean?
represent for?
1/4. That's the probability for us to get a 0 head.
Wouldn't it be 0/4?
Okay, let's check. Remember, probability is how many something divided by something, is that right?
Mm-hmm.
So we are asking how many cases we have 0 number of heads. Tell me, out of those 4 outcome here, how many cases they have 0 number of heads?
Only 1 case
Only 1
contains
case.
it.
That's right. It is 1. It's not 0. Okay, it is 1.
Thank you.
Yeah, that's a good question, right? Now, so that table here, right, is a very simple table here. So we call this probability distribution table. All right, let's move on. A little bit more difficult case. If you remember, if we flip 3 coins, what are the possible outcome? Remember, it's like a tree diagram. You have had, like you can continue to break out. And then at the end, how many number of like those possible outcome we have, right? Altogether, we got 8, right? Another way to get 8 is like a fundamental counting rules. Everybody, how many possible outcome for the first coin? 2. Is head or tail, right? How many possible outcome for the second coin? Also 2. How many possibilities for the third one? Also 2. 2 multiplied by 2 multiplied by 2, you get 8 possible outcome, which are those 8 one here. All right, that's the one we learned. We kind of review that, okay? Now, we are trying to write down what's the corresponding probability distribution for the number of heads. Okay, say we are still interested in the number of heads, right? Now we can write down all the possible value for X. So X here we check like here number of heads, we got 3, right? The first one we got 3, second one 2, 2, 1, 2, 1, 1, 0, right? So we can write down the possible value of X is 0, 1, 2, 3. And then we are trying to find out what's the corresponding probability for X equal to 0. So what does that mean? That means I flip 3 coins. What's the probability for me to get a 0 head, right? We check here. out of those 8 outcomes, how many of them they have 0 number of heads? It's only 1, right? Similarly, for 1 head, everybody, how many cases we have 1 head? We have 1 here, right? We have another one. We have another one. So 3 over 8. Similarly, for the 2, right? 3 over 8, right? And for 3 number of heads, how many? We have one case, 3 heads here. Is that right? So the probability is 1 over 8. Everybody, that way here, the table we are getting, what do we call probability distribution? This table here, the possible value of X and the corresponding probability of X. So far, so good, right? Now, if we continue, we realize there are certain information, right? We can summarize based on those table here. So it turns out probability distribution has to satisfy 2 conditions. Everybody, we can check those 2 conditions. Number 1, for all the probability we are getting, they should be always between 0 and 1. Always between 0 and 1. Let's check out, right? The previous 3 cases, everybody. The first case was the corresponding probability, everybody. This one here is all between 0 and 1, right? How about the second one here? Is all between 0 and 1. Number 3 is all between 0 and 1. Corresponding probability, right? Follow me? So that tell us questions.
Yeah, so there can never be a probability of like 1 and 1/8.
Probability of what?
1 and 1/8. So it all has to equal 100% is what you're saying.
Is the maximum value you will get is 100%. You cannot, for example, if you do the calculation here, like X equal to 4, right? You put like 1.5. Something's not right.
It would never work that way because
never
you have to equal 100.
Yeah. We are never bigger than 100%. We are never be negative, for example, right? Remember, this one we mentioned previously, when we talk about a probability, it's like always between 0 and 1. Remember, right? If someone tell you probability of raining tomorrow is 120%, he's either an idiot, he didn't study stats, right?
Could be a
Don't
hurricane.
tell me that coming from my class, especially, right? Okay, now you studied stats, you know what to say, right? Everybody, we don't say probability of something is negative 0.5, right? That is not right. We don't have those. Okay, so everything, whenever we talk about probability, always between 0 and 1. That's the condition, number 1. Any questions? Number 2, when we add all the corresponding probability together, should be exactly equal to 1. If you remember, everybody, this notation here, the sigma notation, right? That means summation, right? That means we add all those probability together should be exactly equal to 1. Let's check out, right? The first one, everybody, if we add all those numbers together, what do we have? It's like 6 over 6. It is equal to 1, right? And one thing I want to mention that previously when we say the probability is always between 0 and 1, right? Someone will say, oh, why do we have like 0, 1, 2, 3? They are not between 0 and 1, is that right? So what's happening? Because those are the possible value of X. They could be anything, right? That's something that we are interested. We are interested in number of heads, we are interested in number of tail, right? Something that we are interested could be any value. What we are trying to say here is the corresponding probability, right? Could be only between 0 and 1, right? Cannot be out of that range. Okay, so the second case, everybody, when we add all those numbers together, right? 1 over 4 plus 2 over 4 plus 1 over 4 is 4 over 4. Is that equal to 1? Yes, right? Similarly, the third case here, we have 1 over 8 plus 3 over 8 plus 3 over 8 plus 1 over 8. That is equal to 8 over 8 is equal to 1. Is that right? So that's the condition number 2 they have to satisfy. Whenever we add all the corresponding probability together, then we will get exactly equal to 1. Now, someone, interested, right? Can we check? What if something that is not satisfied, right? We have some example here, everybody, right? So I give you this table here. It's a very simple, right? Straightforward table, everybody. X and corresponding probability of X, right? 2 rows. And I'm asking, is this table probability distribution table or not, right? So we just need to verify those 2 conditions. Everybody, condition number 1, all the probability between 0 and 1, let's check out. You see this one here, not right. It's not in that range. Something is not right. That means one condition break. What do we say? That is not probability distribution. That's good enough. We don't have to continue, everybody. As long as you find out one condition break, right? You don't have to continue to check the other one. That's good enough to say it is not probability distribution. Follow me? Second example. If we have this table here, given X, right? 1, 3, 5, 7, 9, and corresponding probability here, right? We have to check those 2 conditions. Number 1, all the probability between 0 and 1. Let's check out, right? So 0.3, 0.1, 2, 4, 1, all between 0 and 1. Good. Condition number 1, satisfied. Check. Condition number 2, when we add all those probability together, should be equal to 1. Let's check out. 0.3 plus 0.1 plus 0.2 plus 0.4, right? Plus 0.1. Add them together, everybody. What do you have? Big trouble, 1.1. Something's not right. Because when you add all the possibility together, ideally, it should be 100%. How come you get 110%, right? Something's not right. So condition number 2, no good. What do we say? Not probability distribution. Easy, right? Third example, this X, possible value, 8, 9, 10. And then we have the corresponding probability of X. So we have 2 over 3, 1 over 6, 1 over 6. We check those 2 conditions. Everybody? Condition number 1, those values should be always between 0 and 1. Is that right? Let's check out. Always between 0 and 1. That's right. Condition number 1, good. Condition number 2, when we add all those probability together, 2 over 4, 2 over 3, that's equivalent to 4 over 6, right? Plus 1 over 6 plus 1 over 6, that's equal to 6 over 6. It is equal to 1. Both conditions got satisfied. What do we say? It is a probability distribution. Easy?